So you've jumped on the MCP hype train? Awesome, so have I. But here's the real question. How do you actually integrate MCP servers into your AI agents? I don't know about you, but I'm tired of seeing the same old tutorials of using MCP inside Claude Desktop or building MCP agents using something like Pydantic AI. We need to go beyond that. So today we will be diving deep into designing AI agents from scratch with MCP in mind. You learn how to build agentic loops, structure your workflows, and avoid some common pitfalls. Let's get started. Okay, we're gonna start with the basics for this one. So we know the architecture. Okay, we're not gonna get into that again. We already saw what MCP is in general, right? Okay, let's take a simple example to kick things off. An MCP server is nothing but like a very custom written REST API server. So instead of REST APIs or API endpoints, what you define are tools. Now, to be fair, MCP servers have a little bit more different kinds of APIs. Tools is just one of them. They also have something called resources and prompts. We covered that in the previous stream, so I'm not gonna touch base on that. But a quick overview, MCP servers are nothing but API servers which offer tools. So technically you're doing tool calling over the network. LLM decides to call tools. That's how it works. So there are like 3 different things which MCP kind of supports. Today, we are just going to look at MCP servers over HTTP. Okay, I know we did it in the last stream, but I think it's kind of important. So let's just do it. MCP, it's just servers and clients. However, the MCP which we see in Claude Desktop and things like that, most of them use something called standard input-output. Okay, so Claude is actually running some process and it's hooking into its standard IO. And it's talking to that server over standard input output, right? So there's terminal under the hood and Claude is starting a process and it's plugged into its standard input output. So Claude can send it messages using standard input and can receive messages from it using standard output. It's literally doing some npx start command under the hood to do all of that crap. We are not gonna be doing this, okay? I don't see why anybody apart from something like Claude Desktop would use something like this. Most of our applications will be talking to other services through an HTTP API. You know, that kind of makes more sense, at least to me. So we're just going to avoid this standard IO stuff altogether. It's just so weird because you need the server to be running on the same machine and things like that. It just beats the purpose. I don't know. You know what? It doesn't sit well with me. So we're going to stick with the second transport instead, which is the server sent events. That's what we're going to be focusing on today. We're going to make our clients talk to servers over SSE. Or server sent events, okay? Things get real when you start doing this because first of all, you need to worry about things like authentication, you need to worry about discovery, you need to worry about a lot of things. So we're gonna talk about that. And if you're building your own client or you're building your own AI application, most likely you will be using this or something like this because your client will be talking to like a server over the network. It's going to be like an HTTP request or something like that. Now, let's just dive into the code. I think that's going to be a clear start. So an MCP server is nothing but, you know, a simple server. I'm using the official Python SDK for this. Yes, I had to use Python. But I know a lot of you have been complaining that, oh, why do you use JavaScript? Please use Python. So there you go. Okay, there you go. Cool. So, I mean, these are just endpoints. There's nothing fancy in a server. We can just skip through this, but I'm just going to show you so you know what I'm talking about. The idea is that, you know, instead of APIs, you have these functions instead. So it's like an RPC, you know, a remote procedural call, and you decorate it with this MCP stuff. So I have got 3 tools here. So I've got a get task tools. We're making the task management app. I'll show you a quick demo of what that app is right now, and then we'll convert it into an MCP based agent. Cool. So we have a get task tool. We have a tool to add task. We have a tool to mark tasks as done. Internally, these are all talking to the database directly. Okay. Now, because we are using MCP, okay, you need to start a frigging REST API. And how do you do that? You really need to technically get into the server territory. So I'm using Starlet. You could have used Fast API or something like that. I just went with what ChatGPT wrote for me, technically Gemini. I just went with what Gemini wrote for me, and I'm just using that instead. But the idea is you are creating a simple or not so simple REST API using some HTTP server in Python Like I said, I'm just using Starlet for this one. And this is just a server-side event handle. I don't really want to get into all of this. This is just boilerplate code. Just remember that every MCP server on the network or on an HTTP server just has one important route, which is /SSE, right? It could be any route. In this case, it's /SSE, right? And you just need to have one handler on top of it. And the handler will essentially use the SDK provided by MCP themselves. So this connect SSE and this entire handler is actually exposed by the official library. I'll push all of this code. Don't worry about it. It's all going to be there on GitHub. Just some boilerplate stuff. You don't have to worry about it. Okay. But the important stuff here is this part. You're just adding some tools. Okay. I've got these tools and we don't have to worry about API endpoints or any of that. Remember the boilerplate code we wrote in this Starlet stuff that takes care of all of this. Okay. So this is just like RPC. Pretty much it. It's literally just 37 lines, okay? It's nothing, okay? So I have one server which does task management, like simple get task, add tasks, mark a task as done. And then I have a get events, like a calendar MCP. Just imagine this to be integrated with my Google Calendar, okay? I was really lazy. I did not want to code, so yeah. You know, I've hard coded it. Sure, yeah, sure. Okay, we're doing it, okay? We're just doing this. Cool. So we have two MCP servers. One is running on port 8020 and the other one is running on port 8010. Simple? Yeah, I've started both of these already. So the servers are already running. And that's how it should be, right? In most microservice architectures, or even if you're working with another SaaS company, they would be running the server. You don't have to run it yourself. That just sounds weird. I don't know why does Cloud Desktop do it that way. I mean, it kind of makes sense because people, actually it does not make any sense. You know, let's not talk about the HTTP. We're talking about server-side events. We're going to stick with it. Cool. So that's the server part. We're really not going to get into the server. I think it's pretty standard. It's pretty straightforward. There's nothing fancy here. The fun part is the client. Now let's move on to step one. How do you actually talk to an MCP server? Forget LLMs. Just in terms of code, in terms of Python code, how does your Python code actually, or a Python client, actually talk to an MCP server? Okay. Now, again, there's a lot of boilerplate involved here just because there's an SSE layer. So what is happening is I've made my own class. Okay. This is something I've made just to simplify everything. So every MCP client needs to know which server to connect to. So you need a server URL. Once you have the server URL, great. Then you connect to the server. You actually make that connection. And for people who don't know, server send events is a sticky connection. So when you connect with the server, it's kind of like a sticky session. So the connection is maintained. It's not like request response and you're done with it, okay? So it's kind of notion of a session involved here, which is kind of weird. Yeah, it's a lot of boilerplate code. But essentially what I'm doing is I'm using the MCP library to make an SSE client, like a server send events client. I'm establishing a session then. Again, this session was given to me by MCP themselves, by the library. Now, technically, I shouldn't have done this. I should have used that with stuff, the widths. But I wanted like a long session. Like I wanted my session to last, and I'm really bad with Python, so I don't know how to handle this for a long period. So you know what? It is what it is, okay? I know this is bad code. You're never supposed to do like these enter stuff yourself. You're supposed to use that with keyword. I don't really understand it. I'm not a Python whiz. This is how I'm doing it. Live with it. Okay, cool. I create my SSE client. I initialize it. Okay. Once the initialization step is done, then you can do whatever you want. Okay. This session is essentially your client to talk to the MCP server. And you can do a lot of things with the client. So for example, I can do self.session. So you can call a tool where you're literally calling one of those tools in the backend. You can do list tools, list resources, list prompts. You can do all of that fun stuff. There's a lot of things you can do. Okay. We're just going to worry about tools right now. So what I'm doing right now is whenever I make a successful connection, I'm just going to list the tools and I'm just going to print out the tools, right? Keeping it simple. And then I store all those tools for future use. And then I can even call that tool if I want to. Okay. So how does it work? I create my MCP client. So this is connecting to the task MCP. Yeah, I think this is the task one, not the calendar one. Yeah, get task. This is the task one. Then I connect to the SSE server. And remember, inside this connect function, I was even trying to list all the tools. Okay. I'm just listing the tools so that I can print it out for you guys. And then what I'm doing is I'm using that same client to call the tool. And what this call tool is doing is essentially just using that session call. Hopefully this makes sense, right? It's not that complicated. It is a little bit a boilerplate, like REST is just so straightforward. There are some layers to this, especially because of the SSE stuff going on. Kind of makes it a little tricky. But essentially, whenever you're calling a tool, all you need to do is give it a tool name and give your arguments here. So this would be a dictionary. But since getTask doesn't really require any argument per se, so the argument is none. Makes sense, right? Cool. So this is how you essentially connect with the client. Let's just run this and see how it works. Clear. Now 01A. Yeah. So that was quick. So essentially, we come in and we're listing all of our tools. That's what happens, right? So the first tool we get is getTasks, the description of the tool. Forget this title, just ignore this. And properties, nothing. The getTask doesn't accept any arguments. Then we have addTask, and the addTask tool takes a task, right? It has one property called task, which is of type string. Okay, just ignore the titles. Then we have mark task A as done. Again, it has just one argument, which is of type string. If you go back to our server, that's precisely what it is, right? Nothing fancy going on here. So what MCP has done for us is it's given us a way to dynamically list all the tools we have through the protocol itself, through the SDK or the client wrapper itself, right? And then I can call my tool. So I'm calling the tool here, right? So I'm calling the tool and I'm just saying I want to call the tool. I give the name of the tool, right? GetTask, which is the first tool right here. And it has 0 properties. So I can just give it a none. Doesn't really matter. And then I get a response back and I'm just printing the response. And these are all my tasks in the database. Cool. Sounds good. Pretty straightforward, right? No LLM involved. We're just using an MCP client, making it talk to the server directly, deterministically. Okay, no LLM fancy stuff going on here. We're keeping it simple. Just trying to understand how the code looks like and what we need to do. We can already see how this will work in LLMs. Like that list tool function is going to be very helpful because this is essentially going to give us a list of all the tools, right? This will help us discover what capabilities a server has. And then once you have made a decision to call the tool, you simply call the tool. Pretty straightforward again. So now this is a lot of boilerplate, so the client doesn't look so good. So what I've done is I've gone ahead and created like a cleaner version of this. You know, I made like my own little client manager library, blah, blah, blah. And this does some fun things for us. Essentially what it does is we have a new object client manager. It's just managing a lot of clients because the thing is, the beauty of MCP is that you can add MCP servers on the fly. Okay, that's kind of an important point. So I have a way of listing down my MCP servers. I have a YAML file which lists all the servers. Again, this could be another API. I know that MCP is going to be adding a schema registry soon. So they're going to have some protocol specs around how do you make your own API to discover MCP servers. That could be an interesting thing we can check out. But for now, I'm just using a files-based discovery tool. So I've got 2 servers. One is Task Manager. This is the URL. And I even have this API key for authentication. Okay, we'll get to this. Similarly, for the calendar server, again, it's a different port. So yes, Keenan, you're right. If you're running everything locally without containers, yeah, you're technically going to be having different ports. But again, in a real world scenario, you wouldn't be just running everything on a single machine. Or even if you were going to be using containers. So that's something doable, right? That's how even database works. So I'm fine with it. I can live with it. But yeah, API keys are important. Okay, we have API keys. Now again, I've kept it in plain text because of course, I don't care if this gets hacked. That would be funny. But yeah, you can use environment variables, use a secret manager, do whatever you want. I mean, I'm trying to demonstrate a point here. Okay. And what my library essentially does is it reads this file. Okay. It reads every server in there. It goes and essentially calls add server and it makes that MCP client object for each element inside that array. And that API key essentially gets passed as the authorization header while making the SSE client. Does that make sense? So the API key is essentially an opaque token or a bearer token, which goes in the authorization header. I mean, if you've ever worked with authentication before, like even if you've dealt with OpenAI SDK, whenever you pass an API key, this is exactly how it goes under the hood. It gets set in the authorization header. There's nothing fancy going on here. Now, of course, even if you had OAuth 2 or something like that, you can see it's not that complicated because even in OAuth 2, you're getting like ID tokens and things like that. You could just pass your ID token here. The point is, MCP has no opinion on how you handle authentication. I mean, I don't even need to use the authorization header, even though like most of us do. We could use like an X YourTechBud codes API key. It doesn't matter. Use whatever you want. And on the server, because I'll have to like take care of this on the server as well. So on the server, what I've done is in my handler, remember, we just have one API handler, right? On the /SSE endpoint, right? So what I'm doing in my handler is before I call the handlers of our MCP library, I just added a quick auth check. Now, again, this is not the most secure check. You could even use middlewares if you want. Do whatever you want, man. I just don't know Python really that well. I don't know how do you put middlewares in Starlet or whatever. So, I mean, I just plucked it in here. But the point is, you have a layer, you have an API handler. You could have a middleware which checks for that authorization header. If the API key doesn't match in the database or whatever, then you can throw an exception. Pretty straightforward stuff, right? Nothing fancy. And on the client, things now look so much neater. 01B client. There you go. Yep. You just load the servers. You connect to the servers. Okay. Yeah. Let's just have a look at this as well. So this will connect to each and every server. And remember, every time you connect, you get the tools, right? So what the client manager will do is it's going to take the tool of every client. So it's going to loop over each and every client and it's going to make a consolidated list of tools. Hopefully there are no conflicts. Like if there are two servers with the same name, this will blow up. That's how it's made right now. It's fine. Yeah, you're right, Keenan. Essentially, the client manager is keeping track of all the servers. It's maintaining connections with them and it's tracking all the tools they expose in one consolidated place. So now I have one client talking to multiple servers. How it's supposed to. That's how Cloud Desktop works as well, right? It's just that Cloud Desktop uses STDIO. We are using HTTP because we are big boys. All right, cool. That's pretty much it. So yeah, let's just run this just so that you know that it works. Let's clear the screen first. And then this is going to be a 1B. Yeah, there we go. So all our tools are here. So get tasks right here. And then we have add a task. That's right here as well. Forget the titles. I don't know why this is here. It's weird. It's just the way it is. Then we have mark task is done. And then we have get events. And remember, get events was from the calendar MCP. So now through this client manager.tools, we have a consolidated list of all tools in our server, in all our servers. So if tomorrow somebody adds another server in the list, it doesn't matter to us because this will have all those tools. Now, again, right now I load all the tools at start time. You could have some kind of a loop under the hood, which, polls it periodically, like every 5 minutes or every minute or something to like keep itself updated or whatever. So yeah, there are a lot of mechanisms. I've not done everything. This is just supposed to be like an explainer video, but you're seeing where MCP falls short, right? I hope I'm trying to highlight these points. How you maintain that list of tools, like how I've done right here, this is something up to you to decide. So your application either will fetch the tools every time it wants to make an LLM call right before the LLM call, or you could do something what I have done, like at startup, just get all the tools and then periodically keep refreshing it. All of this logistics and bookkeeping of tools, even resources and prompts for that matter, is up to your client code to figure out. Okay, the client needs to figure that out. If you're using Cloud Desktop is the client which does all of this for you under the hood. How does it do it? I don't know. I don't care. The point is you have to do this yourself if you're building your own application, which I hope you are because we're a bunch of builders here, right? Make sense? This should make sense. This is fairly straightforward. If I messed up the key for whatever reason, and then if I try to run it again, obviously I'm going to get some error and 401 unauthorized. Expected. You can't just mess up the API key from under yourself. So authentication, pretty much straightforward. Yeah, cool. So let's move on to how do you make this available to your LLM? Okay, same code. Just ignore this 4.0 mini. We are not using OpenAI. We are using a local model, of course. That's what we do on this channel. So again, we have our client manager. We're loading all our servers. We connect to our servers. Remember, connecting to the server fetches the list of all tools as well. That's kind of important. Then we ask the user for a query. Right? And now what I'm doing is in my LLM call, like when I'm actually talking to my server. Now, again, I'm using the OpenAI SDK. I'm raw dogging it so that we know exactly what message is going to the server and what isn't. Whenever we have a query from the user, we are essentially making an OpenAI call or OpenAI chat completion request. The user's query goes in here. And now I also passed in a bunch of tools. This is the same tools which our client manager was maintaining for us. How do you manage as the client manager retrieve the input params and return type, we can't resolve it to LLM as is, right? Yeah, that's a very good freaking question, Keenan. So oversimplifying the question a little bit, how do you make sure that the client manager, the list of tools it prepares is shovable here? Like, how do you make sure of that? So what I've done actually is, whenever my clients connect to that server, whenever a single client connects to that server, the first thing it does, once the session has been established, is that it lists the tools. Okay, it lists all the tools. And then my client, because my client knows that, okay, we're just going to be using OpenAI. Okay, this is my client. I can do whatever I want, and I know I'm just going to use the OpenAI SDK. So what it does is it takes the tools we got from the MCP server and it prepares an array of tools which we could directly shove in the OpenAI call, right? So you see here, I'm making a chat completion tool parameter type function. And luckily, there's a very good correlation between these. So what MCP calls a name, OpenAI calls a name as well. What MCP calls a tool description, OpenAI calls it a description as well. What MCP calls input schema, which is this part. Oh, actually, this is my converted format. No worries. But okay, what MCP calls input schema is what OpenAI calls parameter. So this is essentially the input schema. And luckily for us, this is JSON schema as well. So essentially, there's a 1:1 mapping of whatever MCP returns in its list tools to what OpenAI SDK would expect in its tools call. Does that make sense, Keenan? Does that make sense? So what I'm doing is, whenever I list that tools, I'm converting it into my OpenAI list of tools upfront. The way tool handling is done is OpenAI is very, like, we have to follow the SDK, and the SDK works this way, so I have to do it this way. But again, right now we are using this weird JSON stuff, and this is like weird JSON schema stuff. I'm not the biggest fan of this. Like, I don't like seeing this either. There are much better alternatives to do this. Personally, if you ask me, like, hey, you're making Fluidcast, what are you using? I use BAML. So for my stuff, I use BAML, but because I know the final video which comes out on this MCP thing, hopefully it comes out soon. The final video, I want it to be as generic as possible. So I decided to stick with OpenAI. But yeah, you can use any format. I'm using OpenAI because I know that eventually I'm going to make an OpenAI call and I want to use these tools. Now, how do you do tool calling with your LLM or with your SDK? You know that better. If you're using Anthropic, there's a particular way of doing it. If you're using BAML, there's another particular way of doing it. Everybody has their own way of doing tool calling. This is OpenAI's way of doing tool calling. And most of us, including like Pydantic AI and those things, whenever you use like the OpenAI model, it's actually doing this under the hood. Okay. So for OpenAI, for the LLM, it's just a frigging tool. I mean, if I had some local tools as well, there is nothing stopping me from doing something like this. So I could have some of my own tools over here. It's my local tools. And I could have these Anthropic tools and I can like concat them together. How does it matter? For my language model, for my LLM, for my model, it doesn't really matter if the tool is coming from an MCP server or is it coming from my code base directly. It's just a frigging tool call. That's all it is. Okay. The LLM doesn't really care. However, once the LLM gives you back a response, let's say in OpenAI, this is where you get the response, right? And the tool calls. One second. If you just want a good quick look on how the tool calling API actually works. So this is the raw request which goes to OpenAI. Okay. You have a system message, you have a user message, you have your model. That's the model I've been using. You have some temperature. You give your tools like this. Yeah, I don't like this. But hey, this is what the OpenAI spec demands. So you have to give it this way. You don't really have an option. So yeah, so I have a function, some function. The function has 2 parameters, whatever. If I make a call, hopefully this works quickly. My model might have gone to sleep. Not because I'm boring. Oh my God, this is like a self-burn. Yeah. And then the response you get is you get those choices. And inside your message, instead of getting like a text message, what you get is like the tool calls, which is an array. There could be multiple tool calls. And then in the tool call, you get the same ID as the name. So your function name, you get the same ID. Or you get the same name. I honestly don't remember. This is my own server. So for me, it's the same. In OpenAI, it could be something different. And these are your arguments, which is just JSON. So you can parse this JSON and you'll get the object which can be parsed in that function. That's essentially how it works. Okay, that's how the OpenAI SDK works under the hood. So, and we're doing the exact same thing in our code base. So essentially, we're giving it the bunch of tools here. We're getting a response back. And now once we get the response back, now here comes the tricky piece. If you had merged in some MCP servers and some local tools, like some tools which are in your code base. Or if you've merged in tools from various servers, okay, so you have tools from server 1 and server 2, which will happen. I mean, that's the point of MCP, right? That you have dynamic number of servers. Now, whenever OpenAI decides to call a tool, you would need a way to figure out which tool was belonging to which server. Okay, like if OpenAI in this case decides to call the get task tool, you need to know that, oh, get tasks was supposed to be of the task manager server, and that was using that particular session. So you need to maintain this mapping somewhere. As a client creator, you need to create or maintain this mapping somewhere. The agentic frameworks out there, like Pydantic AI, which supports MCP and stuff like that, they handle all of this for you. But again, we are not using an SDK. We are raw dogging everything. So what I've done is in my client manager, I have this process tool calls thing going on. And what it essentially does is internally I create like a map of which function name belongs to which client. So I have like a reverse mapping going on somewhere. Like, yeah, this is where I create the map. Whenever I get the tools in the first place, I just maintain that map that, oh, this function belongs to this client. And of course, you could prefix the function name with the MCP server name. This way, you won't have that namespace conflict scenario going on, which is nice. I mean, there are multiple ways to solve that namespace conflict stuff, but this is one of the ways to do it. And then based on the function name, I figure out that, okay, this was the session. And then on that session, I do the call tool. And of course, remember OpenAI gives us JSON string. So I have to like first load it into an object and then pass it. And that's it. So essentially I get a response from OpenAI. OpenAI will give me a response saying that, okay, we need to call these tools. I loop over those tools. I see that based on the function name of a particular tool, like the first tool, the second tool, the third tool, each tool, I figure out which session was that tool associated with. And then against that session, I invoke this call tool, give it the function name again, and give it the payload, which OpenAI told me to give, like as is. I'm just copy and pasting it. I'm not even verifying anything. I just pass it over, right? And then this is deterministic. This entire call is deterministic. Again, the implementation on the MCP server could be non-deterministic. Like the MCP server could be using LLMs. We don't care. But for us, once OpenAI has made the decision to call a tool, for us, it's completely deterministic, right? This is deterministic as hell. And then what I do is I just keep appending all that results here, and then I return that entire results back, and then I just print it. Pretty much it, right? Pretty straightforward. Connect to all your MCP servers. Under the hood, client manager creates that tool array. Then when calling our model, we need to pass those tools. In the response, hopefully a decision is made to call the tools. If it has, then you'll have to make sure that you find which session was that tool associated with it, and against that session, do this call tool, which we did earlier in the first example. Yeah, that's pretty much it. Nothing fancy. Okay, this is as straightforward as it can get. But at least now we know what's happening under the hood, right? Enter a query. Give me my task. Give me my tasks. Let's run this. So processing tool called get tasks. So the model decided to call get tasks, and it's giving me all my tasks. Now let's say give me my events for the day. And it chose to call get events, and it got the results back. Now, at this point, you must be thinking, wait, what is so special about MCP anyways? Or does MCP really change the way we write clients? So let's try to answer that question now. Oh, spoiler? Yes. It does change the way you write clients, okay? So now to be fair, for a large language model, you're just calling tools. It doesn't really matter if it's MCP or not. But for your application, there are some things changing. Earlier, the number of tools you had to call was predictable. You had a fixed number of tools. You knew exactly what had to be done. So your agentic workflows would be extremely deterministic. What do I mean by that? Okay, let me give you an example here. YTB codes. Let's look at our first stream we did. One of the first streams we did, Pydantic AI. I think the example we came up with over there is really good. So essentially, it's a task management app. I can show it to you in action if you want. It's right here. Clear. Let's zoom it up. Clear. Yeah, and there was 04, was it? Nope. You know what? I'm just going to write it again. UV run source 04. Yep. So essentially, we had this task management agent. What it does was you can give it a question. So I can say, give all my tasks. And then the first thing it did was it used something called the intent classifier to figure out, oh, the user actually wants to get tasks, right? And then it goes to the task executor with the prompt, get the tasks. The task executor decides to run a tool called read tasks. And read task gives us the array of tasks. And then it goes to a summarizer here. This is the summarizer. And the summarizer goes and, takes that JSON/YAML array and converts it into something we can read. Hey, you made some good progress. Thank you so much. Oh my God, this is such a cute model. Thank you. I appreciate it. I appreciate the kind words. Cool. Pretty deterministic, right? My tools are deterministic. Everything is deterministic. Yeah. The flow for this app is going to be very straightforward. Like, again, we ask for the user's query. Then we essentially use the intent classifier agent, which gives us a result. In the result, we get an action. If the action was add task, you call the task executor with saying that, okay, just add the task. If your result was get task, then you say that, okay, first get all the task, and the result of that, use that to generate a summary. If the task was supposed to be marked as done, then first see if that title actually exists and then mark it as done. Pretty predictable. However, now things have gotten a little complicated in our MCP land. In our MCP land, whenever the user says get tasks or get events, the meaning can change now. What I mean by that is there could be multiple MCP servers which get tasks. For example, some of my tasks are in Notion. Some of my tasks are in a Todoist app or a To-Do app. Some of my tasks are in my calendar. My tasks could be distributed across the board. How do you know which MCP servers are allowing you to get those tasks? So things are getting a little dynamic now. If you've architected your agents the right way, there should ideally be zero change in your code. But you do have to consider the nuances that, okay, there are multiple MCP servers now. And somehow we need to rely on the LLMs to make an autonomous decision that, wait a minute, the get tasks could be fulfilled by multiple players or multiple MCP servers. Similarly, the user could say, okay, get me all my events and tasks. So the user is asking for two things now. The first thing would be retrieved from maybe the calendar MCP, and the second thing would be from the To-Do app, whatever it is, But you get the point. There is some more autonomous decision making going on under the hood now. Let's try to see how that works. Okay. Now, to be clear, in the Claude desktop world, everything is an autonomous decision because Claude desktop has literally no idea what you're trying to do. It has made the most generic agent on the planet, and it's relying on a really good model under the hood to make it all work, right? In the real world, we want the blend of autonomous decision making and controlled workflows. So we kind of want a good balance between the two. So we still want to preserve the workflow, but at the same time, we do want to give our agents enough leeway so that they can go and explore and try to figure things out themselves. So this is the primary difference when you're designing agents, where the number of tools are dynamic. So again, it's nothing to do with MCP. The problem is because your number of tools are dynamic. So let's see how I did it. Now, I'm not saying this is the way to do it. This is just one example, one way to do it, okay? And I wanted to keep this simple. So this is literally something I've been writing right now. So what I've tried to do is I've still tried to preserve my overarching workflow, wherein I still start by classifying my intent the same way I always did, right? Classify the intent. And after the intent, if the intent was get read tasks or something like that, use better names. Actually, I copy pasted the old code. We shouldn't have used the word task here. It should be something like read, query or something like that. Doesn't matter. Cool. Yeah, it's get task. But what I've done here is there's a while loop. Actually, let's just go through the code. It might be a little intimidating, guys. I'm sorry for that. Let me just walk you through it. What's happening here? Okay. I have a array of messages, and it's just two messages. I have a system message, which says that, hey, read the query and decide what tool to call, essentially. Then I have a user message. The user message is essentially, we need to answer the user's query. First, gather all the information you need. Only make one tool call at a time. This is the information we have so far. Information is an empty array, by the way. And once all the information has been gathered, summarize the information and return the answer to the user's query. Okay, so summarize at the end. So first gather information. This is the information we have, and then summarize it. And finally, this is our user's query. Okay. Now what I'm doing is, again, this is inside a while loop. So inside the while loop, what I'm doing is just some, debug stuff. So I'm again doing my OpenAI call. Right? Actually, I wanted to show something that, okay, I have a tool which is local and I have some tools which is MCP, but I couldn't make it work. Sorry. Yeah. Okay. You know what? That doesn't matter. We're just using the tools from the MCP server. Okay. We're using the tools from the MCP server. We're getting the messages. Remember, in the first loop, the information is empty. No information. Cool. Then we get a response. If the model decided not to call any tool at all, we're going to return the message. Otherwise, if the model does decide to call a tool, we'll use that process tool call, which we saw previously. And the result of that tool call will append it in the information array. And then again, we go back to the loop. But when we go back to the loop, the new messages array, which we have, that will have some information. It will have information that, okay, we have information of the first tool call. Then again, it could do the same thing again, and then it might decide to call a tool again, and then we add that information again to that information array. And then the next time it runs, it will have the information of both the tools. Hopefully, it's a big hopefully, eventually the model decides that, okay, there's no more tool to call. And that's when it's null or when the length is 0, that's when we say, okay, you know what, it's time to return now. So what I've done here, we still have that overarching workflow. Now, again, this is such a trivial example that I couldn't make it any more complicated because you need some complication to show these concepts, right? It's a fairly trivial example, I'll concede to that. However, we have an overarching workflow which still decides whether you want to get a task or whether you want to mark a task as done or something like that. But if it was get tasks, because we could have tasks from so many different MCP servers, we are letting the model go wild inside a while loop. Now, this while loop could be infinite, like in my case, or you could say that, okay, the maximum number of iterations is 5. So you can just do 5 iteration at most, or maybe 10 iterations at most. You decide your limits. The client, as in the developer, has to decide those limits. And then I have made the conscious decision of using all the tools here. So we are also passing in tools which technically modify tasks or cancel events. You could have filtered those tools. Nobody's stopping you from doing it. Like here, I'm just taking in all the tools and shoving it right in the tools list. Maybe that's not the best approach. Why is that not the best approach? Because if you had like 100 different tools, your model will get confused. Okay. So maybe you want to filter this before you actually call the model. Okay. But the point is, we're letting the model iterate and, keep looping over and over and over and keep calling a tool till it finally decides that, oh, you know what, we're pretty much done. There's nothing more to call, and now we'll return. This is what we call React. Pydantic AI, that React agents, which, started with that LangChain era. This is that. However, most people who do React, essentially, they keep appending to this messages array. I have not done that. I have appended to the information array, and I've made sure there's only one user message. Multiple ways of implementing React. So the point I'm trying to make is React is not generic enough that you could just say, oh, implement it once and we're done. Every use case would want to implement React a bit differently. Like here, I've used information. Maybe in your case, you might do something different. This is one way of letting agents figure out what tools to call and get the final answer. This is one way of doing it. Actually, you know what? Let's draw this out. I think it'd be fun to draw it out. Let's open a handy tool, Excalidraw. You should definitely check out the previous stream on MCP. That was epic. That was like so good. So we have a user, right? The user starts with a query. Now, what we've essentially done is we go to the LLM and we can mark LLM in red here, right? Because that's the indeterministic part. The LLM may decide to call a tool. LLM was not deterministic. Tool is deterministic. So the LLM may decide to call a tool, may being the keyword. Once we get the response of the tool, we make some changes in the actual user message or the user prompt going to the model, and we let the model keep looping. Eventually, the model decides that, hey, I'm done, and you have the final answer. This is the React style loop, which I was talking about. This is one way of doing it. There are multiple other ways of doing it. One big one is, again, you have the query. Let's start with the query. Another big one is the plan act method. So you have a planner agent or a planner LLM call. So this guy needs to be aware of all the different tools which are there, or it could be the different agents which are there, and things like that. Or different MCP servers which are there. I mean, it really depends on the use case, right? So this would be like, oh, there's a calendar MCP, there's a to-do app MCP, there is a Notion MCP, and it would make a step-by-step plan. And what it would do in its plan, it would say something like, oh, you know what? In my plan, first call the Notion to see if there are any tasks in Notion, check out Todoist, and then check out the calendar. But in calendar, just check out not the events, just tasks. So the real question becomes, how does the planner even know that the calendar MCP server has a concept of events and tasks? How does it know that Notion has tasks? How does it know that Notion has tasks? Notion, it's just a note-taking tool, right? It's not necessary that it has any tasks. So the planner process can only be effective if it has a clear glimpse of what are the individual tools within each MCP server. So it's a little complicated to implement a good planner. So for our use case, a planner pattern would not really work well. But again, if all the ingredients to make a plan is somehow available to the planner, then it just makes a list. And now what you could do is, you don't even need an LLM. You could need an LLM. It really depends. You know what? I'm going to put a complementary LLM here to figure out the parameters of the tools to be called. It actually depends. And this is going to be like a self loop. It's like calling itself. It's like looping over itself. This is not a good self loop. Let's try to do it again. This is much better, right? So it's kind of like looping over itself for the entire plan. And once the entire plan has been executed, then you end. Something like that. You get the point, right, guys? You get the point, right? You can even combine these two together. You could even have like a planner thing, and then the planner goes ahead and executes the plan. And after every step, you let an LLM decide if the plan needs to be changed or do we need to continue on the plan or something like that. The point is, you can combine these two steps. So one is a plan step where you try to plan ahead and you try to plan ahead in time and then execute the plan. The second is you don't have a plan. You go one step at a time, or you directly start doing the work, and then as you're doing the work, you try to figure things out. And of course, you can combine them together. These are the primary ways I've seen loops work. I'm not going to claim that this is an exhaustive list. That will be stupid. And that is why having strict agentic frameworks might not be the best idea, because these loops which we just saw, how do you know which loop is applicable, or if you need to combine things together, or if you need to do something weird with your prompts or something like that? It's just so use case specific, So that's why whenever somebody comes up and says that, oh, my agentic framework supports MCP, I'm like, what does that even mean? What do you mean by MCP support? So I think most people, at least the ones which I've seen so far, what they mean by MCP support is that they have this loop internally and they have a process or they have some functionality to make those calls like this one, which is not all that hard. I literally wrote this entire code in like an hour or two. It's not that hard. What's hard is figuring out how that loop works. What works for your use case. So again, now this, I've not really tried it out a whole bunch. It doesn't work as well as I would like it to, but you know what? Let's give it a run. Let's see if it makes me proud. Let's give it a query. So let's start with something simple first. Give me all the tasks. So it's gonna go ahead. Oh, my model went to sleep. Yep. It decided that it wants to read the task. Then comes our system prompt, and our system prompt decided that, okay, this is a system prompt. Then our user prompt, the information is empty. The model decided to call get tasks. So now we fired another request. So this is like the second loop. And this time we are saying that, hey, we have some information. And the information is what? It is that, okay, get task, this is the result, and blah, 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 whatever. And then the user went ahead and said that, oh, the user wants all the tasks. We already have that list. So we don't need to call any functions. Answer to the user's query right here. So we lose a little bit of formatting flexibility if you use like a very generic agent. Again, what I could have done is I could have written another agent which looks at all the tool call results and summarizes it itself. Maybe a 32 billion parameter model is not the best person to do that summarizing along with that decision making. Maybe it's, because see, it's getting these kind of things inside. Kind of annoying. So yeah, some downsides of making things automated, you might want to take control back. But now let's give it something more complicated. Let's do this. Give me all my task and events. Let's do that. Technically, it should do two calls now. So again, the first request goes in. Very good. No information. It decides to call get tasks first. Sweet. Then it made the second call. In the second call, it had that information. Yes, it made the decision to call get events. Then we added the get events to this list somewhere here. Yeah. I know I did not format this really well. Again, I was literally making this 5 minutes before the stream. It wasn't working. And then this guy finally decides that, oh, cool. You know what? The user has got all their tasks. No function call is necessary. These are all your tasks. These are all your events. There we go. It works. Yeah. That is pretty much it. I see absolutely no questions. I think that's a win, right? Next stream is actually going to be on something really cool. We are going to work with voice agents, real-time voice agents, without using the real-time API. So I think that could be really cool. Like, share, and subscribe if you found this video to be helpful. And don't forget, I am your tech bud. You're on YouTube and hopefully in real life.